All right, so we are in the same place as we were before for the absolute value function y equals the absolute value of negative 3x squared minus 1. Determine the x and y intercepts, sketch the graph, state the domain and range, and write as a piecewise function. So I'm just going to set up my graph here. Boop. Oh. Don't forget my arrowheads. Manitoba loves arrowheads. And I'm going to say that this is 1 and 2, and this guy right here is 2 as well. So if I were to just graph, I'm going to say y equals negative 3x squared minus 1. Okay, it's stretched by a factor of 3, but it doesn't move left or right. It just moves down 1. So I would say, okay, so my vertex is going to be at, if I, my x-intercept is, my y-intercept is going to be when x equals 0. That's going to be at negative 1. So we got that right there. And since it's not moved left or right, that is my vertex. Okay, and then we get stretched by a factor of 3. So instead of going 1, and it opens down 2. That's another thing. So instead of going over 1, down 1, we go over 1, down 1, 2, 3, and here. And usually we would go over 2 and down 4, but I don't think that we have 12 here. 1, 2, 4, 5. No, we do not. So we're just going to be fine with these 3 like that. Now remember, parabolas are not like linear. Okay, even though they get stretched, there's actually still a curve to that front there. Okay, so I'm just going to label this right here, y equals negative 3x minus 1. Oh, sorry, negative 3x squared minus 1. So if we were to graph the absolute value of this, we wouldn't say that it's at 0, negative 1. We would say it's 0, 1. Right there. And we wouldn't say it's at 1, negative 4. We would say 1, positive 4, like that. And not negative 1, negative 4. We would have negative 1, positive 4. Okay. So then we would go like this, and we go like this. And we would say this guy right here is y equals the absolute value of negative 3x squared minus 1. Great! So, let's analyze this, shall we? A. Determine the x and y intercepts. So the y-intercept happens at y equals 1. X-intercepts. Are there any x-intercepts? No. Interesting. None. Don't say 0 because it makes it seem like the x-intercept is right there. B. Sketch the graph. Check. C. State the domain and range. Now, it's actually going to be greater than, not greater than 0. It's actually going to be greater than positive 1 for the range. But let's first start out with domain. So domain is going to be x such that x is an element of the reals. Or we say that it goes x's are between negative infinity and positive infinity. The range y such that y is greater than or equal to 1. Y is an element of the reals. Or 1, positive infinity. Boop. Okay, and that is because it doesn't have any x-intercepts. It doesn't ever intercept, so that means whatever is happening below is fully happening below. It doesn't ever cross the x-axis, and so then when we take the absolute value of that function, everything simply happens above. There's no touching of the axis. And in piecewise notation, so in this case, since there's no crossing over, we just say no piecewise notation needed. because there are no critical points. Which means that there are no x-intercepts or no zeros. Okay? Because there are no critical points, there's no abrupt changes in the function that's available. And because of that, no piecewise notation is needed. I mean, I guess I could say, okay, well, y equals, since it's all changed, I can say y equals 3x squared. Y equals 3x squared plus 1 for x, all x's belonging to the reals. I could say that, though it's the piecewise notation is no longer needed.